In this short video, we are going to look at how reactions happen. This is the start of your topic on rate of reaction and is really important to help you to understand the rest of the topic. Your keywords for this lesson are collisions, particles, frequent, and successful, and you should make sure that you know what all of those words mean before you start. So collisions is when particles come together and crash into each other or collide. Particles can be atoms or molecules or ions. Frequent just means often. So if something happens more frequently, it happens more often. And successful is specific to the term collision. So a successful collision is a collision that results in a chemical reaction. So here I've shown you a chemical reaction that you will have seen lots and lots of times. So this is the burning or the combustion of methane gas. So methane gas comes in through the gas supply and goes into the bottom of a Bunsen burner. When it reaches the air hole, it mixes with oxygen from the air, and the oxygen can react with the gas, and we can get a chemical reaction. The reaction taking place can be shown in a word equation like this. So we've got methane from the gas tap, reacting with oxygen from the air, which is entering the air hole of the Bunsen burner, and this is creating carbon dioxide and water, and the hot gases that are being created are seen as a flame. So this is hot gases leaving the top of the Bunsen burner. Now, collision theory tells us that the reason this reaction takes place is because of collisions between the oxygen molecules here and the molecules of methane gas. So the molecules of the two different chemical substances have to collide with plenty of energy, and when they do, they can react. So collision theory is all about particles colliding with each other and causing a chemical reaction. Here is another example of a chemical reaction that could take place in a classroom. So we have got paper on the desk, and paper obviously is flammable. We know that it can set on fire, and when something burns, that's just reaction with oxygen in the air. That's what we've learnt at school. So in the room, there are particles of oxygen, and these particles of oxygen are colliding regularly with the paper. But as they do, they collide and they bounce off. And this is because the oxygen particles and the paper particles do not have sufficient energy to react. So although the collisions are happening, these collisions are unsuccessful collisions because they're not resulting in a chemical reaction. However, if you were to take the oxygen molecules that are colliding with the paper unsuccessfully and provide some heat energy by lighting a match, as oxygen molecules hit the paper, they would have enough energy to react, and this would become a successful collision and will lead to a chemical reaction. So in this instance, the paper would burn because the energy of the particles is high enough. It's really important that you know the difference between successful collisions, which have plenty of energy and lead to a reaction, and unsuccessful collisions, where particles simply bounce off each other because they don't have enough energy to react. So you need to know that in order to react, particles must collide with sufficient energy. That means with enough energy. The energy needed for a reaction to take place is called the activation energy, and it is really, really important that you know that term and you know what it means. So activation energy is the energy needed for a reaction to take place. It's the minimum amount of energy. That is the least you have to supply to get that reaction going. So to use this term in context, here we've got a paper sitting on the desk and oxygen molecules are unsuccessfully colliding with the paper and the reaction is not taking place. This is because the particles involved in this particular reaction do not have the activation energy. They don't have the minimum energy required to get the reaction to go. So again, if we supply energy, so as the oxygen molecule is coming in to hit the paper, if we supply some energy in the form of heat, then this now becomes a successful collision and results in a reaction. So try your best to get used to using these terms such as activation energy, successful collision, and unsuccessful collision, and that's how you can use them. Now this topic is all about rate of reaction, and rate just means speed. It's how fast the reaction is going. And you probably know from everyday life that some reactions happen very, very slowly. So this is rusting. This is where iron turns into iron oxide over time. And some reactions happen incredibly quickly. So this is an explosion. so a very, very quick reaction. So this is all to do with collision theory. The particles here of iron and oxygen are colliding to form iron oxide, and the particles involved in this reaction are also colliding. But there are factors at play that cause this reaction to happen faster, and this reaction to happen slower. So things we can do to speed up the rate of a reaction, to cause a reaction to go much faster, are things like increasing the temperature, because by increasing the temperature, you give the particles more energy. More of those particles would have activation energy, and so that reaction would be able to go faster. You could also do things like increasing concentration. So if you put more particles in the same volume, then the likelihood of them colliding in the first place is already increased. So more particles in the same volume, that's an increase in concentration, is another way that we could make the particles collide more frequently, and hopefully there'd be more successful collisions within there. So the reaction would go faster. In the next tutorial, we'll look a little bit more at how we can measure the rate of reaction, and then we'll go on to look at all of the different factors that speed up rates of reaction one by one. So that's it, just for a very short introduction to how reactions happen, and obviously leads into a whole load of other tutorials as well, and it's really important that you watch all of those. But for now, you should go and show what you've learned on the online quiz.